In this demo, we will explore Stackdriver features such as logging, monitoring, trace, error reporting, and debugging. With Stackdriver logging, you can view all log messages from your applications. Here are the details about a log message. You can search your logs for specific information. For example, you can search for log messages that have an HTTP response code of 200. A response code of 200 indicates that the request was completed successfully. You can then create a logs-based metric for this condition. Let us call our metric HTTP 200 and put in a brief description. Navigate to the Logs-Based Metrics section. Here is the metric that we created. You can create an alert from this log-based metric. This takes you directly to Stackdriver Monitoring, where you can configure your alert policy. For example, you can set an alert to notify you when the number of successful HTTP requests is below 400 per second for 5 minutes. You can add a notification to send you an email or notify you on the Cloud Console mobile app. Stackdriver Monitoring can also send notifications to PagerDuty, SMS, and more. You can add documentation links or a message to provide more information about the alert. To summarize, you have now created an alert notification based on a logs-based metric. You will receive notifications whenever the number of successful HTTP requests drops below the threshold that you have specified. Let us dive deeper into Stackdriver Monitoring. The list of resources is automatically populated based on the resources in the projects that you are monitoring. For example, Stackdriver Monitoring detects that we have an Apache HTTP server agent installed on an instance. It automatically creates a dashboard with the metrics that are commonly used. Stackdriver Monitoring displays an overview of alerts that have been detected related to this resource. Uptime checks can be used to check that your resources are up and running normally. You can create and view information about uptime checks. For example, you can set up an uptime check by specifying a URL, App Engine Endpoint, Compute Engine Instance, or Elastic Load Balancer. Stackdriver Monitoring will then periodically check the status of the resource. Here is an uptime check for the URL shown on the screen. From here, you can create an alert policy to notify you if the page is slow or unresponsive. Stackdriver Monitoring enables you to create dashboards to view your monitoring information. Here is a custom dashboard. This dashboard displays metrics gathered from AWS and GCP. It shows the network inbound traffic for an Amazon EC2 instance and network outbound traffic for a Google Compute Engine instance. The ability to view monitoring data for multi-cloud environments in one single location is a really powerful feature of Stackdriver Monitoring. Let us now look at Stackdriver Trace. Stackdriver Trace shows latency data between time intervals. For example, what was the latency between requests last week and this week? You can view system-generated analysis reports. Here we have a report that shows a major change. There is a significant difference in latency between last week and this week. Latency has improved this week. Stackdriver Error Reporting displays errors that have occurred in your applications. Click on an error to view details. You can look at the stack trace to determine where the error occurred. Clicking the source code file in the stack trace takes you to Stackdriver Debug and the line of code that has a problem. Stackdriver Debug creates a debug snapshot on this line. When the application hits the line of code again, Stackdriver Debug creates a snapshot of the application state, including values of local variables. Note that this application was running when we set up the debug snapshot. We did not restart the application to get new snapshots. This powerful feature of Stackdriver Debug lets you inject logging information without interfering with the normal function of the application.